Today we are going to evaluate graphs and talk about the functions and talk about how the generalization of the directions of your graphs. Now, we'll notice all these ones at the top, these are odd degree functions. The ones at the bottom, okay, those are even degree functions. Okay, and on odd degrees, okay, notice the direction to the right when the leading coefficient is positive, it goes up. And if the leading coefficient is negative on the right, it goes down. Okay, if the leading coefficient is positive, and then on the left it goes down on a odd degree function. Okay, now that was a negative, so it went up on the left. Then our evens, they're like a field goal. Okay, if it's positive, if the leading coefficient is positive on even degrees, okay, it's like a field goal. Both sides go up. If it's negative, okay, both sides go down, like a frowny face. Okay. So our odd degrees have two different ways they can work. Okay, if it's odd degree and a positive leading coefficient, so leading coefficient, then the right goes up to infinity, the left goes down to negative infinity. If it's an odd degree and the leading coefficient is negative, then the left goes up to infinity and the right goes down to negative infinity on the y. If the degree is even and the leading coefficient is positive, both ending behaviors on the left and the right go up. If the degree is even and the leading coefficient is negative, then both sides on the left and right go down. What this essentially means is we can look at any graph and tell you if it has an even or an odd degree. So if I had a graph and it goes like this, and notice that this side went down, okay, this side went up, well, we know right now that the ending behaviors are in opposite directions, so it's odd. Okay? And the right side goes up, so we know that it's a positive leading coefficient. Okay? So it doesn't change at all. If it was like this, okay? Well, now both left and right are going up, so that means it's an even degree and a positive leading coefficient. Okay. So, same thing here. We're going to look at graphs and we're going to tell you what the degree is, odd or even, and what the leading coefficient is, if it's positive or negative. So, in this one, okay, it's even because they both go the same direction, and it's negative leading coefficient. Okay, this one's odd because they go opposite directions, and the right side goes down, therefore it's a negative leading coefficient. Okay, now we're going to graph this, okay, and we're going to tell. But first we can pretty much figure out how the end behaviors are right now. Okay, the leading coefficient is negative, and it's an odd degree because 3 is odd. Okay, so that tells me a negative that the left was going up, the right's going down. Now I go and I plug this into my calculator. Okay, and when I plug it in, this is how it should look. Okay, that was your x to the third, negative x to the third, plus x squared, plus 3x, minus 3. Okay, when you plug that in, okay, then this is what it should look like right there. Okay, these are the values you'll end up with. And that's the sketch of the graph. So now we need to plug in all those values, okay? So we end up with, we got to make our table, and those are our values. Obviously, we can't get negative 324 on the graph, but we can get negative 2, and we know that that point's like up here somewhere. We're fine with that. So negative 2, 3 would be right there. Okay, negative 1, negative 4 is right there. Okay, 0, negative 3 is right there. 1, 0. 2, 1. 3, negative 12, which is down here. Okay, then we look at our graph, okay, and we sketch that a ways. And there's our graph. And our ending behaviors were exactly how we thought they were going to be when we predicted them. Okay, so let's do another one of those. Again, we got x to the fourth minus x cubed minus 4x squared plus 4x. Okay, it is a even degree. So we know that the ending behaviors are going to go the same direction. And it's positive leading coefficient, so each side is going to be going up at the end. Okay, I plug this into my calculator, okay, which is x to the fourth minus x cubed minus 4x squared, so write that down. Now we plug it into our calculator. Okay, this is the graph of that. Okay, these are our values. I'm going to translate those values over. Okay, how you find these values is you hit second, okay, and then graph. So let me use the red here. Right here, second table, okay, table, and that's where you find that. Okay, so I'm going to translate these values over, and then we graph this. Negative 376, we're not going to get on there. Negative 2, negative 212, which is about right there. Okay, negative 1, 2, 0, 4, 1, 0, 2, negative 4, 3, 22, which means that that's just going to be up, way up here. Okay, we look at that graph again just to get the sketch of it. Okay, and then we sketch it. And there's a sketch of our graph. And notice that our end behaviors are exactly what we predicted. Okay, again, let's decide what this is. This is an even degree because both are going the same direction, and the leading coefficient is positive. Okay, we graphed this one. I'm just going to tell you right now, okay, it's a leading coefficient is like that. Okay, and it's positive, so because it's even degree, positive, both ends are going to go up. We graph it on our calculator, and this is what it looks like. Okay, and if I was to translate it over, that's what we'd get. Okay, and we should sketch that down and show that we knew what we were doing. Last thing here, okay, we are going to describe the end behavior. Okay, and essentially, when you describe the end behavior, you're just going to write this down right now, f of x as it goes to, and f of x just means y. Okay, as it goes, and we're going to have that as x goes to negative infinity, which means as x goes to the left, what happens to y? And then you're going to have as f of x, or y, right, goes as x goes to the right, or infinity. Okay, so right here, okay, when we look at this, the leading coefficient, okay, is negative. And it's an even degree. So our end behaviors are going to look like this, down and down. So as we go to the left, okay, which means as we go this way, y goes down to negative infinity. Okay, as we go this way, or as x goes to infinity, y is still going down to negative infinity. Okay. This one, okay, again, this stuff's not going to change. As f of x goes to as x goes to negative infinity, and as f of x as x goes to infinity, okay? Well, all that's saying is, well, first we got to look at this. It's negative, okay? And it's odd, which means that on the left it's going to go up, on the right it's going to go down, okay? So as x goes to negative infinity, or as x goes to the left, y goes to infinity, because y is going up. Notice, y is going up as x goes that way. Okay, and as x goes this way, y goes down, or y goes to negative infinity.